In the second part of section 3.9, we're going to take the derivatives of logarithmic functions. Recall again from pre-calc 30 that logarithmic functions are the inverses of exponential functions. So you notice we have the exponential function e to the x in blue, and we have its inverse, which is the logarithmic function ln x, and notice that they are symmetrical to the line y equals x. So we're going to have to learn how to differentiate common logarithms, and common logarithms would be one that would be, say, to the base 2, and natural logarithms, which might be something like that. And a natural logarithm is really just log base e. So instead of writing log base e, mathematicians just write ln. Okay, so let's take a look at our first example. So if I want to take the derivative of this, the rule is I go 1 over whatever the function is within my logarithm, which is x squared. And then I also have to divide it by the natural log of whatever the base of my common logarithm is, which is ln 2. And then I times it by the derivative of the function inside, which is 2x. So now if I simplify, this x eliminates one of those. So my final answer is going to be 2 over x times ln 2. So here is the rule for the derivative of common logarithms. Again, it's 1 over the function inside the logarithm times the natural log of whatever the base is times the derivative of whatever the function inside the logarithm is. So if we take a look at this guy here, we want to take the derivative. So again, be careful that this 3 is just on the x squared minus 5. So therefore, y prime is going to be, this 3 is a constant. So it's going to be 1 over x squared minus 5 cubed times the natural log of 4. And then I must multiply it by the derivative of x squared minus 5 cubed, which is the chain rule. So it's going to be 3 x squared minus 5 to the second times 2x. And if we were to simplify this, I have 2x times 3 is going to give me 18x. And then I have x squared minus 5 squared over x squared minus 5 cubed times ln 4. And then that guy will cancel out 2 of those. So my final answer is going to be 18x all over x squared minus 5 times the natural log of 4. All right, in this next example, we're going to look, there's a property of logarithms that says if I have the common logarithm of a number, which is a base a, and my function when inside my logarithm is a raised to another power, this really works out to be whatever the exponent is, which is sine x. So again, for this rule to be true, this base and this base have to be the same, and then the function is just the exponent. So now the derivative of sine x is equal to cos x. The only reason I did this example is there is one like this in your assignment from your Calc 30 textbook. Okay, the natural logarithm is much easier. The rule for the natural logarithm is 1 over the function within the logarithm times the derivative of the function. I do not have to divide by ln of the base, which would be ln e, because ln e is equal to 1. So to take the derivative of this, it's going to be 1 over 3x times the derivative of 3x, which is 3. And this ends up being 1 over x. This next example, I need to use the product rule. This is my first function, and this is my second function. So y prime would be my first function times the derivative of e to the 2x, which is itself, times the derivative of the exponent, which is 2, plus the second function times the derivative of the first, which is 1 over 4x squared times 8x. So this is going to simplify to be 2e to the 2x times ln 4x squared plus this 4 cancels out to that to become a 2. This x takes out one of those. I'll be left with 2 over x times e to the 2x. And now I can take out a greatest common factor of 2 and an e to the 2x. And if I do that, I'm going to be left with ln 4x squared plus 1 over x. Okay, in the next example, I have a logarithm of a quotient. So again, to figure out the derivative, it's going to be 1 over the function inside. And then I must multiply it by the derivative of the function inside, which is the quotient rule. So it's going to be the denominator, which is 3x plus 1, times the derivative of the numerator, which is 1, minus the numerator, times the derivative of the denominator, all over the denominator squared. And that question would get you 4 marks. 1, 2, 3, 4. And now you get a couple of marks for simplifying. So again, I can reciprocate this denominator here, get 3x plus 1 over x minus 4. And if I clean up the top here, I end up with 3x plus 1. When I distribute, I'll get minus 3x plus 12. And this is all over 3x plus 1 all squared. So now this 3x plus 1 cancels out one of those. Inside this numerator here, I collect like terms and get 13. So my final answer is going to be 13 over x minus 4 times 3x plus 1. And that would be my final simplified answer. Okay, here's an AP multiple choice question. So they're giving us the function, which is a natural logarithm of this trinomial, and we want to find the derivative at 0. So again, to find the derivative, it's 1 over the function times the derivative of the function, which is going to be 1, plus the derivative of 4 is 0, plus the derivative of e to the negative 3x is going to be e to the negative 3x times negative 3. So now I can evaluate this at 0. So I'm going to get 1 over 0 plus 4 plus e to the negative 3 times 0 times 1 plus e to the negative 3 times 0 times negative 3. So this ends up being, I'm going to get 1/5 down here. I'm going to get 5 in the denominator. And this is going to be 1 plus 1 times negative 3 is going to be negative 3. So this ends up being negative 2. So my final answer is negative 2/5, which gives me the answer to be A. Okay, in this particular case, we have to use what's called logarithmic differentiation because this question has a variable raised to the variable. So the first thing I'm going to do is I'm going to take the natural log of both sides. And using my rules for logarithms, my exponent can come out front. And now I'm going to take the derivative implicitly. So on the left-hand side, I'm going to get 1 over y times dy dx equals, on the right side, I have to use the product rule. So it's going to be the first function times the derivative of the second plus the second function times the derivative of the first. So if I clean this up, I'm going to get 1 over y dx equals, well, x times 1 over x is going to leave me with 1 plus ln x. And then to get dy dx by itself, we're going to multiply both sides by y. Get that. And now the question will probably replace y with x to the x, because that's what y is in the original question. So the final answer is something like that. So again, I haven't seen a ton of these show up on an AP exam, but there was one on a multiple choice. So anytime you have a variable raised to a variable, you need to use logarithmic differentiation. And there is one like this for you to do in your assignment from your AP Calc text. Okay, the last question, I'm just going to do part A for this question. And part A is saying we have the function f of x is ln x over x, and we're also given the derivative. And we want to write an equation for the line tangent to the graph of f when x is e squared. So again, kind of a goofy point, but sometimes they'll give you funny numbers to work with, and you just have to trust your mathematics. So the first thing I'm going to do in part A is I'm going to find the y coordinate of that point. I'm going to plug e squared into the original function. Again, using my laws for logarithms, if I have an exponent, I can bring it in front of my logarithm. And ln e is equal to 1. So therefore, this just ends up being 2 over e squared. So my point is e squared and 2 over e squared. Now, to find the slope, I need to evaluate the derivative at e squared. So this is going to be 1 minus, whoops. This is going to be 1 minus ln e squared. So 1 minus ln e squared over e squared squared. So again, this is going to be 1 minus, the 2 can come out front, ln e is 1, and this becomes e to the 4th. So this slope is negative 1 over e to the 4th. So I have my slope, I have my point, and again, my point was e squared and 2 over e squared. So now to find the equation, I just substitute into the point slope formula. And the equation of the tangent line is going to be y minus 2 over e squared equals the slope all over x minus e squared. And again, it doesn't ask you to write it in any particular fashion, so you would just leave it in that form. You don't need to simplify it any further. Okay, so that concludes the end of derivatives of exponentials and logs, the end of section 3.9, and that concludes our unit. So there's your assignment from you have a handout, and you also have some AP Calculus questions from AP Calculus text. So give those a try, and if you have any questions, you can ask me in class.